Have you ever wondered what lies at the center of the universe's most massive and mysterious objects? Well, prepare to be astounded because scientists have recently uncovered a behemoth black hole that dwarfs all others in comparison. Meet TON 618, the largest black hole ever discovered, with a mass over 66 billion times that of our Sun. In this video, we'll dive deep into the secrets of this cosmic titan and explore the fascinating science behind one of the most awe-inspiring discoveries of our time. How big might black holes get? A team of scientists now suggests black holes could reach what they call stupendously large sizes, each harboring the mass of 100 billion suns or more. Currently, the largest known black hole, powering the quasar TON 618, has a mass of 66 billion solar masses. TON 618's enormous bulk led scientists to speculate whether or not even larger black holes exist, and if there is any upper limit to their sizes. The 5 massive black holes were discovered. 5. NGC 6166. NGC 6166 is a beast having a total mass of 30 billion solar masses. It is an elliptical galaxy with an active nucleus in the center. It is about 490 million light-years away in the A-Belt cluster in the constellation of Hercules. NGC 6166 is one of the most luminous sources in terms of X-rays. The supermassive black hole at the center of this galaxy powers 2 symmetric parsec-scale radio jets in the opposite direction. This is a result of the infall of gas into its center. It has been proposed that there are many O-type stars near the center of the galaxy. Also, a peculiar thing about NGC 6166 is that it shows a blue shift E is moving towards us. 4. H1821 plus 643. The fourth in the list of most massive black holes is H1821 plus 643. Identified in 2014, back then it was considered the most supermassive black hole. The mass of this supergiant is more than 30 billion solar masses. Termed a quasar, this black hole boasts a gigantic mass of over 30 billion solar masses. The black hole is located in the constellation of Draco at a distance of over 10.4 gigalight-year. Besides being massive, H1821 plus 643 is quite big. If it were at the place of the Sun, the Schwarzschild diameter of this black hole extends to the orbit of Pluto. 3. S514 plus 81. This is the most interesting one on the list. S514 plus 81 has a mass of about 40 billion solar masses. It is a blazar. Blazars are the most energetic of all subclasses of quasars. It is one of the most luminous quasars with a total energy output of 1041 watts. If a quasar were at a distance of 280 light-years from Earth, it would give out as much energy per square meter as the Sun does at Earth, despite being 18 million times more distant. The quasar's luminosity is therefore about 3 × 300 trillion, times the Sun, or over 25,000 times as luminous as all the 100 to 400 billion stars of the Milky Way galaxy combined, making it one of the most powerful objects in the observable universe. 2. IC 1101. IC 1101 is the most massive galaxy known in the universe so far. It is a supergiant elliptical galaxy. Being elliptical, it is devoid of gas, and hence the star formation rate in this galaxy is very low, just like other ellipticals. The black hole at the center of IC 1101 has a mass between 40–100 billion solar masses. This ultramassive black hole is a bright radio source. 1. TON 618. The list of the most massive black holes is topped by TON 618. TON 618 is technically a hyperluminous, broad absorption line, radio-loud quasar, located near the North Galactic Pole in the constellation Canes Venatici. It contains the most massive known black hole, with a mass of 66 billion solar masses. A black hole of this mass has a Schwarzschild radius of 1,300 AU, about 390 billion km in diameter, more than 40 times the size of the TON 618. As a quasar, TON 618 is believed to be the active galactic nucleus at the center of galaxy. the engine of which is a supermassive black hole feeding on intensely hot gas and matter in an accretion disk. The light originating from the quasar is estimated to be 10.8 billion years old. Due to the brilliance of the central quasar, the surrounding galaxy is outshined by it, and hence is not visible from Earth. With an absolute magnitude of -30.7, it shines with a luminosity of 4x 1040 watts, or as brilliantly as 140 trillion times that of the Sun, making it one of the brightest objects in the known universe. Like other quasars, TON 618 has a spectrum containing emission lines from cooler gas much further out than the accretion disk in the broadline region. The size of the broadline region can be calculated from the brightness of the quasar radiation that is lighting it up. The emission lines in the spectrum of TON 618 are unusually wide, indicating that the gas is traveling very fast. The full-width half maxima of TON 618 has been the largest of the 29 quasars, with hints of 7,000 kilometers/s speeds of infalling material by a direct measure of the AP line, an indication of a very strong gravitational force. From this measure, the mass of the central black hole of TON 618 is at least 66 billion solar masses. This is considered one of the highest masses ever recorded for such an object, higher than the mass of all stars in the Milky Way galaxy combined, which is 64 billion solar masses and 15,300 times more massive than Sagittarius A*, the Milky Way's central black hole. With such a high mass, TON 618 may fall into a proposed new classification of ultramassive black holes. A black hole of this mass has a Schwarzschild radius of 1,300 AU, about 390 billion km in diameter, which is more than 40 times the distance from Neptune to the Sun. Lyman Alpha Nebula. The nature of TON 618 as a Lyman alpha emitter has been well documented since at least the 1980s. Lyman alpha emitters are characterized by their significant emission of the Lyman alpha line, a special wavelength emitted by neutral hydrogen, 121.567 and wavelength in the vacuum ultraviolet. The nature of the Lyman alpha line being strongly absorbed by the air in the Earth's atmosphere, making identified Lyman alpha emitters only limited to objects in the distant universe due to their high redshift. TON 618, with its luminous emission of Lyman alpha radiation along with its high redshift, has made it one of the most important objects in the study of the Lyman alpha forest. King of the universe. Like most things in space, there is still a lot to learn about these mysterious dark objects, and although TON 618 is currently the black hole king of the universe, there may well be another, even larger one waiting to take that top spot. Within the Milky Way galaxy alone, it is estimated that between 10 million and a billion black holes exist, many of which lead to isolated lives, making them impossible to detect. We can only really observe the gravitational effects of the most active, most massive, and most extremely positioned black holes in the universe. This means that we have only discovered a tiny fraction of what might be out there. Because light cannot escape, black holes cannot be directly observed. But we can detect them using special telescopes that can see how matter is affected around a black hole, allowing scientists to study these mysterious objects further. Although these cosmic monsters are effectively invisible, we have managed to image the hot disk of material that encircles one. In conclusion, TON 618 is a testament to the awe-inspiring power and complexity of our universe. The largest black hole ever discovered, it has expanded our understanding of the immense forces at work in the cosmos. As we continue to study TON 618 and other massive black holes, we may unlock new insights into the evolution of galaxies and the fundamental nature of space and time. While these mysteries may seem daunting, they offer a thrilling challenge for scientists and explorers alike. If you found this video informative, make sure to hit the like button, share it with your friends and family, and subscribe to our channel for more exciting content like this.